All right, so what I was saying was, if you look at the left-hand side, the left-hand side that we have found here, the left-hand side is just equal to our right-hand side. So our right-hand side is just this part. It is just this expression there. And then this expression there is equal to, this right-hand side is just equal to the left-hand side, which implies that this formula that we have here is valid for all positive integers of n. So this is how simple mathematical induction is. So let's quickly move on to the next part. I don't know if there is anyone with a question. If you have a question, kindly ask just right here before I move on to the next page. If you have a question, ask. All right, it seems everyone is understanding what is happening. So let's quickly move on to the next page. Okay, so this is just the solution of the first question. Yes, so this is just a solution of the first question there. Let's move on to this question. So example 2 is also question 2 from your tutorial sheet, which is tutorial sheet 6. So don't be scared when you see a question. On mathematical induction, the steps that you follow when solving questions, all the questions are just the same. So step 1, if you are solving such questions as this one, the first step that we had was in the previous question was we first test the given formula with a p of 1. So we test the given formula with p of 1. This is what we're also going to do. Step 2, we put, for step 2, we assume that since it has accepted for p of 1, then it is also true. Since it is true for p of 1, then it is also true for p of k. Step 3, you say since it has accepted, rather it is true for p of k, then it is also going to be true for the next value in the sequence of natural numbers, which is just going to be k plus 1, meaning it's going to be true also for k plus 1. So that is how you solve such questions. So let's quickly solve these 3 questions, then I think we call it a day. Yeah, we call it a day. So for today, these are the questions that we're going to do, and then if you are doubting your answers, you can try to solve certain questions from the tutorial sheet there and see if you are managing to solve. If you have any challenges, you are free to text me on WhatsApp, and I'll respond to you as soon as I see your text. So let's quickly proceed. So the first step, we test this expression that we've been given with p of 1. Let's try to see if it's going to be true for p of 1. So let's try to put 1 there. So when you put 1 there, they are telling, okay, the question here, when you've read the question here, it's telling us to say n to the power 3 plus 5n is divisible by 3. So we have to prove using mathematical induction that for all positive integers of n, this expression is divisible by 3. So let's try to test. We try to put 1. So I'm trying first to test p of 1, or rather, let's say we try it when n is equal to 1. So meaning while there's n there, let us try to put 1. So I'm going to have 1 to the power 3 plus 5 times 1. So when you have such an expression there, let us now simplify it. We have 1 plus 5. So 1 plus 5 will give us 6. Is 6 divisible by 3? Can 3 go into 6 without leaving a remainder? Yes. How many times? 2 times. So we have proved, and it has accepted, the answer that we have gotten here is divisible by 3. So we have proved. So now we can say this expression is true for p of 1. So it's true for n is equal to 1. So this expression is true for n is equal to 1. So after doing that, we can now move on to the next step, which is step 2. So this was our step 1. Let us now look at our step 2. So in our step 2, what we're going to do, we'll also make an assumption that since it is true for n is equal to 1, then it is also going to be true if our n is equal to k. So if n is equal to k, this also is going to be true. So what do we do now? This simply means that while there is n in this expression, I'm going to put k. I'm going to have k to the power 3 plus 5k. K to the power 3 plus 5k. So when I do this, I know to say this part here is divisible by 3. How? Because how or why? Because I've proved that for the first statement there, for the initial value of n, which is n is equal to 1, it was true. So meaning even this one is supposed to be true. And this simply means that when I divide this expression by 3, I'm going to get, when I divide this expression by 3, I'm going to get a certain number which I don't know. So I'm going to call it any letter. I'm going to put r there. So when I divide this expression by 3, I'm going to get the answer, which is r. So when I cross multiply there, r over 1, so 3 times r to be 3r, and then 1 times this expression to be that expression. So this is just simply just writing the same things as, this is just the same as saying okay, let me just write this. When I divide that by 3, I'm going to get something like this. So 3 times this r, I'm supposed to get that. So I'll keep this expression for future use. So since it is true for n is equal to k, so I'm also going to go to my third step there where I'll say my other n which I'm going to use is the next number, which is just k plus 1. So the next number there is k plus 1. So in this expression where there is in this expression there, in this expression where there is n, I'm going to put k plus 1. So I'm going to say k plus 1 to the power 3, and then plus 5, and then we have k plus 1, like that. This is equal to, so this can also be written as k. So if you want the simplest way you can do this, or in simple explanation, try to make this part at least, or try to find this part in this expression there. What do I mean? Let us simplify this part this side. So when we simplify this part, we're going to have k multiplying by k squared. So I'm just trying to simplify this. You can use any method to expand that. So I'm going to do this 2k plus 1, and then plus k squared plus 2k plus 1, and then I'll write this 5 times k. 5 times k is just going to give me 5k, and then 5 times 1 will give me 5. So this is what I'm going to have. So when I simplify this part, I'm going to get k to the power 3 plus 2k squared. So 2k squared plus this k squared, I'm going to get 3k squared. 3k squared. And then this k times 1, I'm going to get k. K plus 2k, I'm going to have plus 3k. So I'm going to have plus 3k. Oh, sorry, I don't know why I'm writing this 5. Okay, so I'm going to have 3k. And then apart from that, I'm remaining with a constant here, which is a 1. Yeah, and I have a 1 there. So there's a 1, or this 1 plus that 5, I'm getting a 6. So before I write that, let me first write this 5k. I'll write that 5k there. And then I'll write this 1 plus 5, I'm getting a 6. So the reason why I've not added this 3k to this 5k is because I'm trying to look for this part in this whole expression. So I'm going to get this 5k, I'll combine it with that in order to get that. So I'm going to have k to the power 3, and then I'm going to have plus 5k. So this 5k, and then I'll write the remaining things. I'm remaining with, so this is plus 3k squared plus 3k plus 6. So while there is 5k to the power 3 plus 5k, I mean, when there is k to the power 3 plus 5k, I'm going to replace with 3r. So I'm going to have my 3r there, and then I'll say this plus, I'll write it there, and then I'm going to write the remaining things there, which is 3k squared plus 3k plus 6. So if you look at all these terms here that we have found, this is 6, this is 3, this is 3, this is 3. So when you look at them, aren't they divisible by 3? Check the first term there. The first term is 3r. 3r divided by 3, it is r. 3k squared divided by 3, it is k squared. 3k divided by 3, it is k. And then this 6 divided by 3, it is 2. So meaning all these terms are divisible by 3, which implies that this expression here is divisible by 3 for all positive values of n. Or if you want, you can go further by factorizing this, meaning you factor out the 3. So meaning this part here, which is the left hand side, this one is, can also be written as 3, and then you open brackets, you are going to have r. I'm just factorizing this expression. I'm going to have r plus k squared, r plus k squared plus k, and then plus 2. So this is what we're going to have. So when you factorize this, this is simply just telling you to say, this 3 can go into this expression how many times? This number of times. Hence, uh, the hence this given expression is divisible by 3 for all positive integers of n. So do we have any questions on this question, so that at least we move on to the next question? If there are no questions, we can proceed. This question has ended. This is how you solve it. So we proceed to the next question. All right, so the next question here is this one. They're telling us to say we have to show that this expression is divisible by 4. So the way I solved the first question is the way you solve this one. Let me first solve this, because time may end up finishing without us doing this one. This one at least has new things in it, but this one, exactly the way I solved this one is the way you solve this one. So let me move on to this one here, so that at least we cover at least uh, at least 2 different questions, not just solving the same question. Okay, we have this. So even this one, the first thing that you do, you test this when n is equal to 1. So when n is equal to 1, you're going to put 1 where there is n. So we're going to have a to the power 1 minus b to the power 1. So this will just give you a minus b. So this a minus b, can a minus b go into a minus b? Yes. How many times? 1 time. So meaning this expression is true for n is equal to 1. So if it's true for n is equal to 1, we proceed to the next step. So we say this is true for n is equal to 1. So true for p of 1. So if it is true for p of 1, we quickly move on to the next step. So the next step, we're going to have our n being equal to k, meaning while there is n there, we're going to be putting k. So we're going to have our expression there, which is just going to be a raised to power k minus b raised to power k. So when we divide this by a minus b, the answer that we're going to get is simply just going to be a minus b times. So when we divide this by a minus b, we're going to get r as the answer. When you divide this by a minus b, you're going to get r as the answer. So when you cross multiply, this is what you're going to get. All right. So I'll solve this very quickly because my laptop may switch off anytime soon. Yeah. So we equally had no power here. So I was just using the battery of my laptop. Okay. So this divide by a minus b, this is what we're going to get. So we quickly now move on to finding this same expression when n is equal to k plus 1. So meaning while there's k there, or rather where there's n in this expression, we're going to put k plus 1. So I'm going to write this. I'm going to have a to the power k plus 1 minus b k plus 1. So this can be written as, so this part can be written as a to the power k times a to the power 1. So a to the power k times a to the power 1, this is what is there. And then we can also write for b, b is going to be b to the power k, and then times b to the power 1. So having written this, we can also write this now. We can use what is called a 0. So a 0 can be any number. It can be any number. Maybe when we add 2 minus 2 to this expression, 2 minus 2 will give you 0. So when we add it to this expression, it's just the same as adding nothing to the expression. So let us try to see a 0 that we can add to this, so that at least we have this factor in this given expression. So how can we add that? So I can simply say when I come to factorization, I'm supposed to remain with a to the power k, and then minus b to the power k. I'm supposed to remain with this factor there. So meaning what I'm going to add there is, first let me put my a to the power k times a to the power 1, and then so meaning I'm going to add negative b to the power k, and then a to the power 1. And then this side I'll add the same thing, b to the power k, and then a to the power 1. And then I'm going to have this part now, which is b to the power k times b to the power 1. So when you look at this part here, which I've written here, this is just the same as nothing. When I add negative this plus that, I'm getting a 0. So which is just the same as adding nothing to this expression. So let us proceed. Let us quickly proceed. So I'll factorize on this part. Okay, there's a question here. There's a hand. Okay, what's your question, please? Harry, the battery is running low. What's your question, Harrington?
How have you expanded?
Yes.
How have you expanded?
Huh?
How have you expanded?
No, I've not expanded anything here. I've not done any expansion here. I just said I'm adding a zero. When you look at this part, when I say, okay, imagine that to this expression, I add 2 minus 2. If I add 2 minus 2 to this expression, does it mean that I've added anything to this? I've added a zero.
No.
This 2 minus 2 will give me a zero. Same applies to this part. When you look at this part which I've written here, let me just change the color of maybe uh, of the ink so that I say what I'm trying to talk about. Okay, let me just say maybe I use blue. Okay, so look at this part here which I'm going to circle. This part. When you add these two, you are simply going to get a zero. Try to add them. This part here, this part which I've circled here, this is a zero. Meaning what you only have in this expression is just this and that, which is just already there, what we had there. I've not expanded anything, but I've just added a zero there.
Oh,
It's like
okay. I get
you've
it.
understood.
Yes, sir. Thank you.
All right. So I've not added anything to this expression. It's just like adding 1 minus 1 to the expression, which is just 0. Okay, so here now I can factorize. So when I factorize, I'm going to have what is common there between these two expressions. It's a to the power 1, and then I'll open my brackets there. I'm going to have a raised to power k, and then minus b raised to power k, and then close brackets. And then I'm going to have plus what is common there. I have b to the power k as the common factor, and then open brackets, I'm going to have a minus b in that expression. So here what I'm going to have, when you look at this part, I'll write my a first, and then when you look at this part here, this middle part here in brackets, try to look at it, compare it with what we have there. This and that is equal to. So if this and that, if these two are equal, yeah, if these two are equal, yeah, these two, if they are equal, it means and we know to say this is equal to that. Meaning while there is this expression in this expression there, we can also put that. So I'm going to replace that expression by a minus b times r. So I'm going to replace that by a minus b times r. And then I'm going to have plus b raised to power k, then open brackets, a minus b. So here now we can factorize. So you can factorize here. Which one is common there? A minus b is common. We have a minus b there and also there. So a minus b is common. Let us also write the remaining things here. So we have on the first term what remained was ar. Then on the second term what remained was b raised to power k. So what remained on the second term there was just b raised to power k. So this is what I found. So when you look at this, this is just the same as those expressions that we were finding where maybe after expanding everything this side, and then we get something like 3 times maybe r plus k plus things that this other side, we were finding something like this. And from this, we concluded to say if 3 is able to be factored out of the given expression, or I mean of the expression that we have found, it means that 3 is a factor of what we were given. So even in this same case, it's the same. We have we are able to factor out the a minus b, which implies that a minus b is a factor of that expression, of this expression, because after simplifying this, after simplifying a raised to power k plus 1 minus b raised to power k plus 1. We found this. So after simplifying, yes, so after simplifying this expression, this is what we have found, which implies that a minus b is a factor of a to the power n minus b to the power n. Hence, in conclusion, you say, since the left hand side here is, I mean, since this part, let me just use a pointer. So since this part here is a multiple of a minus b, then, or if you want, you can say since a minus b is a factor of this part, I forgot to write on this part, then a minus b is a factor of a to the power n minus b to the power n for all positive integers of n. So I don't know if you have understood, you guys, but if you have not understood, I've recorded this session and I'll post it as soon as I finish teaching so that you may have time to go through it. So this is basically what you need to understand. So the most important thing when you come to these expressions having powers there, what you just need to understand is the aspect of uh, okay, what you just need to understand, or what you just need to know how to find, is this part there. Once you just know how to find this part, then you are done with all these questions which are in this format. So this is how simple mathematical induction is. So I know you guys, if I continue maybe to teach even question 3, you get more confused. First, you go and go through some questions in the tutorial sheets. In the tutorial sheet about this same topic, about the topics that we have covered, these two topics that we have covered, dividing mathematical inductions, this is just the extended mathematical induction principle. So you just go through question 1 and question 2 for the meantime, so that on Monday when we meet, I want us to go through question 3, because I cannot teach question 3 if you have not fully understood question 1 and question 2, because question 3 involves certain principles that may end up confusing you. So the best is first you go and go through question 1 and question 2, and then we are going to come and go through question 3 on Monday. All right, so thank you very much for attending today's lesson. If you have any questions, you can ask before I end the meeting. Do we have any questions? Okay, it seems like there are no questions. So thank you very much for watching today's lecture. For being part of today's lecture. So make sure that you don't miss the next lecture that I'm going to send. Make sure that you attend. If you are not missing, I guarantee you to get an A+ in mathematics. There is a way in which there's a way in which the people that I teach, you're not the first group that I'm taking. I'm taking a lot of people. There are people that I'm taking in school here, and there are people that I took years back, and they all celebrated. They all got my A's, A+, B+, when the time when, after writing what's this mathematics. So please make sure that you attend all the lectures that I'm going to be giving you. See you in the next lecture that is going to be on Monday. Shalom, shalom.